Hello there, welcome to video 58. This one is on simultaneous equations. The keywords here are simultaneous, eliminate and variable. Now, simultaneous means at the same time. Eliminate means to get rid of, and variable is something that is a changeable thing within a question represented by the letters. Okay. Now, the method here is to label the equations, multiply one or both to ensure the numbers in front of the letters are the same for one variable, relabel if you've done this bit. That bit's not always necessary, all right? And in question one, it isn't necessary, so we won't be doing that step in question one. Then we've got add or subtract the equations to eliminate a variable, always need to do that. Solve to find the value of an unknown, always need to do that. Substitute back into one of the original equations to find the value of the other unknown, always need to do that. And then check, and it would be a good idea to always do that. Okay, so I will go through this a little bit slower in a second when I'm doing the questions themselves. Alright, now this first question here, we're going to label it equation 1 and equation 2. So what we've got are two equations, okay, with two unknowns in, and we can't solve unless we either eliminate or substitute, rearrange and substitute. Now these ones have been set up so we can eliminate the terms, and we're going to eliminate the y terms. And then we're going to find the value of x, and then we're going to substitute in to find the value of y. So we have an x solution and a y solution at the end of doing this. And what you need to remember is that if these symbols here are in front of the thing that you're trying to eliminate are the same, i.e. if they're both positive or they're both negative, this is the key thing to remember, you will always take away. Alright, so you put a takeaway in between these, takeaway in between these, and a takeaway in between these, okay? And you just put a little line underneath, just do a little bit of a takeaway. So you're doing a column method of subtraction. And this is because 2y minus 2y, so positive 2y minus a plus 2y, is nothing. We have nothing there. We've eliminated the y term from this one. It's only worked because the coefficient of the y term, i.e. the number in front of it, was the same. Okay, so we didn't need to do that first step. This is a nice, simple simultaneous equation. Not that simultaneous equations are simple at all. So we take this away from this, that leaves us nothing there. The equal symbol's there. 17 take away 11. Well, that's 6. And then 3x take away x is 2x, and that's all we've got left. Then we solve this simple one-step equation. Okay, so I've added or subtracted, so I've actually subtracted the equations to eliminate a variable, done that. And I've got the x unknown left, so I'm going to divide both sides by 2 to find out what 1x is equal to, which is 3, and I've found the value of x. Okay, so now we do the substitution bit, sub into equation 1. Alright, that's all I'm going to put. Then I'm going to go 3 times 3, which is, I know, 9, because I think the value of x is 3. Okay, so that's going in there, 3 times 3. Remember, a number next to a letter means multiply. So that's then going to be plus 2y equals 17. Okay, take away the 9 from both sides, and that leaves us with 8. That might take me so long. And then divide both sides by 2, y equals 4. Okay, we found the value of y as well, and then all we need to do to make sure we got guaranteed marks on this 3 marker, this would be sub into 2 to check. You don't always have to write that. I'm just doing that to show you what I'm doing. So I'm substituting the values of x is 3 and y is 4 into the second one and see if it works and makes 11. If it makes 11, we've definitely got the right answer. So x is 3, 3 plus 2 lots of 4, 2 lots of 4 is 8, 3 plus 8 is 11, and it works. So therefore we've got x equals 3, and at the same time, simultaneously, y equals 4. Okay, and that's that. That's how you do a nice one. And 2, this is how we do a slightly more nasty one. Okay, now we label it, do the same thing, 1 and 2. This is where we have to multiply one or both to ensure the numbers in front of the letters are the same for one variable. Now we could choose to multiply this entire equation here, the first one. We could multiply it all through by 2, right? And we could multiply this second one all through by 5, because they are the numbers that are in front of the x terms, right? So multiply by the opposite equations, the coefficient of the term you want to eliminate. I'm going to eliminate the y terms because I want to show you what happens when the signs are different here. Okay, in front of the x terms the signs are the same, and therefore you would take away, and it doesn't matter what you do because it would always work out. It's just really tricky with the negatives, positives and negatives bit, right? So I'm going to make the y terms the same. So I'm going to have to multiply equation 1 needs to be multiplied all through by 3. Okay, and equation 2 needs to all be multiplied through by 2. And that's going to give me equation 3 and equation 4, which I will use to find, eliminate and then find the value of the x's. So that's going to give us 15x if we multiply by 3 plus 6y, and that's going to equal 38 multiplied by 3. So 30 times 3 is 90. 90 plus 24 is 114. Okay, we might get a calculator for this one if we were lucky. Then we've got 2 multiplied by 2x, it's going to give us 4x, and then we're going to have minus 6y, and then that's going to be 38 if we multiply by 2, 19 by 2. Okay, now this here, we've got a plus and a minus. Now, if the signs are different, like they are here, then you have to add the equations. Okay, that's our key thing to remember, and that's because of the rules of adding, subtracting positive and negative numbers, and it seems counterintuitive, but it isn't. 6y plus minus, there's a plus and the minus here, we've added this plus in, the plus and the minus here makes it stay as a minus, alright? If we'd put a minus there, then a minus and a minus would have made it a plus, and then it wouldn't have been eliminated, alright? And that's the bit where people make so many mistakes. So that's now gone, the 6y minus 6y, no y's. We've got 15 x's, and then we add 4 x's, and if we add 4 x's to 15 x's, we've got 19 x's. Okay, and if we have 114 plus 38, I'll tell you, I'm going to bring the calculator in because I can't be faffed with trying to do mental arithmetic at this hour. So it's 114 plus 38 equals 152. And then we're going to divide that by the 19, and we're going to see what that is. Good, it gives us a whole number, so that gives me some faith that I've got everything right so far. X equals 8 here. I've just gone up there because I couldn't squeeze it in anywhere else. Let's just sub into, and it doesn't matter what one you sub it into, let's put it into equation 2. Alright, because that looks a bit nicer. 2 multiplied, well, it's got a negative there, but it doesn't really matter which one we do. So let's put it into equation 1 because it's all positive there. So 5 multiplied by 8 is 40, and 40 plus 2y is equal to 38. Take away the 40 from both sides, it leaves us with minus 2. 2y is equal to minus 2, therefore y is equal to minus 1. So that's what we think it is, and then we check to see if it works in the other equation. So I put it into 1. I'm going to put that into 2 now. So that's going to be 2 multiplied by 8, which is 16, minus, and then 3 lots of 3 multiplied by minus 1. So if you've got minus 3 multiplied by minus 1, that's actually a positive 3. 16 plus 3 equals 19. Okay, so you multiply the two negatives together and you get a plus, right? That's, again, some people might get a little bit tripped up there. So 16 plus 3, 19, check. Good, definitely got the right answers. X equals 8 and y equals minus 1. Going slightly outside the box. Don't ever do that on your exam paper. It won't count. Right, now, number 3. Let's see what we got here. This is a worded one. So when you've got worded problems, you form your simultaneous equation from the words. All right, and this one's not too bad. You can get some ones that are really horrible, but I mean this is bad enough. So let's see what we get. If we've got 5 adult tickets and 3 children's tickets, to a football match costs £174. 2 adult tickets and 1 child ticket costs £68. Find the cost of each type of ticket. So let's set them up as equation 1 and equation 2. Oops. Done it a bit small, but 5 adult tickets. I'm going to put 5a and then plus 3c is equal to 174, and then I've got 2a plus 1c equals 68. Now, this is not as hard as the second question, but it was hard because it was in words and we needed to form it ourselves. So what I'm going to do, I'm actually going to make the C terms the same here. Wouldn't matter again if I made the A terms the same, but it's easy to make the C terms the same because all I need to do is multiply just equation 2 through by 3. If I do that, then I've made the C term 3. So that's going to be equation 3, and I'm going to deal with that, and I'm going to deal with equation 1. I'm then going to ignore equation 2. I'll just cross it off after I've multiplied everything through. So that is going to be 6a, and then that's going to be plus 3c, and that's going to be 68 multiplied by 3 again. I'm just going to bring that calculator in. 68 multiplied by 3 is 204. Okay, now don't need that one anymore because I've got this one. And then I'm just going to write equation 1 underneath it because that's got 5a's there. I can see that we need to subtract the C terms and this number's less. Alright, so I'm just going to do that, set it up like that, and then I'm going to do my taking away. Okay, so what is the difference here? A is equal to 6a minus 5a is 1a. These two have disappeared, and this would give us a difference of 30. So an adult ticket is 30. I'll just write that there. Well, in fact, I've already written it there. I was going to write it down the answer space, but I'm not going to at the moment because I've got to check my answer first. Substitute it back into equation number 1. So that's going to be 5 lots of 30 is 150. So 150 plus 3 lots of C is 174. Take away the 150, leaves me with 24. 3C is 24. C would then be 8. So I think that that's right. Then I'm going to check to see about what it would be in the first equation. I crossed it off, probably shouldn't have crossed it off, or in the second equation. 2 lots of A is 60, 60 plus 8 is 68, and that works. Alright, so I've got A, adult ticket is £30, and a child's ticket equals £8. There we go, we've solved that contextual problem where we need to solve form and solve our simultaneous equations. Alright, once again, thank you very much for watching. Thank you for all the support. Thanks for the lovely comments from all the students that are giving me lovely comments at school and saying nice things about watching the videos. I really do appreciate it, and I hope you are getting something good from it. I genuinely hope it really does improve your chances of getting a decent GCSE. Alright, and maybe inspires you a little bit to do more and more maths, because I found when I did it, when I went through my journey of getting better at maths, I started to enjoy doing it a lot more because I was able to do it. I was actually found I was quite good at doing it. So thanks so much, and I will see you, or you will see me, in the next video, if you watch one.